All right. So yeah, today I'm only recording on my QuickTime player rather than GoToMeeting. All right. So Surya's question is that can we install Pig on Windows? Yes, we can. And we can also install Hadoop on Windows. That's what HD Insights is about. Because Hadoop is anyway written in Java, so it is not impossible to install Hadoop on Windows. It's just that so far people did not try to install Hadoop on Windows and hence Pig. Also, even if you are not installing Hadoop on Windows, still you can install Pig and run in local mode, pig -x local, without installing Hadoop, just to test things out. Alright? And the other mode, of course, is to have a virtual machine on Windows and run everything inside virtual machine. That's another option. But I would strongly recommend that you use Cloud Labs. If Hadoop one is over populated, then if Hadoop 1 is overpopulated, then you can use Hadoop 2, Hadoop 3, Hadoop 4. Because Pig as a client takes some memory, and therefore the local machine on which you are connected to might become the bottleneck sometimes. Right? If there are multiple other users logged into same machine. Alright? So if I'm correct, I think we were on group by, or did we finish group by? I think we were on join, is it? All right. Okay. So join is one of the reasons why would you like to use pig instead of any other, instead of say MapReduce, classic MapReduce. Reason being that the MapReduce, when you try to create a join using MapReduce, it's actually quite a hectic work. Okay, as you must have seen in our last question related to democracy, where we were trying to join two files. Okay, one file containing who voted for who, and second file containing the worth of people. We were trying to join those two files. Although for people who are coming from databases, joining two tables is a very common thing. It's very common thing. And but in case of a pig, in case of MapReduce, joining two tables is a little hectic work. Therefore, pig's join comes as very handy, and this pig's join will be very useful to us. Okay. So you can join two tables in pig only on equality, meaning the value from one table should be equal to the another. We cannot have joins where we try to compare the two. Like in case of databases, we say select star from A comma B, where A dot column 1 should be greater than dot column 2. That's the kind of join which is not supported by pig yet. Okay, it's not supported by pig. And Second is, so here we say join first table and then by one column, comma, second table by another column. And what would it do? It would basically bring all the records from bring a record from first table and the second table together. All right. So it will find out all the records from daily whose symbol is matching with div's symbol 1. As per you can see the line, this particular line, correct? Now you can also join on two columns. What does it mean by joining two columns? Values of those two columns should be equal to the values of the other two columns from the other table. All right. So exchange comma symbol, the both values, both exchange as well as symbol should be equal to exchange and symbol in divs. That is composite key. All right. So you can either join on one column or two columns or more than two columns. Then this is something called self join. In case of our normal database, in case of our normal databases, it was okay to join a table with itself. Specifically, when you are trying to find out a relation between a table and itself. For example, employees table where there is a manager listed in the same table. So, and manager is also an employee. So to find out who is whose manager, or to find out the names of one person's manager, it would be the only way would be to join the table with itself. Correct? That is called a self join. So in case of a self join, what you do is you load two tables. In case of pig, if you try to do self join, you cannot join a data set with itself just like that. You will have to load the two tables separately. You'll have to load the two tables separately and then join. Okay? Meaning, unlike the databases where we did not have to load a table twice, we just joined the table with itself. Here you have to have a little bit more, uh, little bit more work. You have to execute the same statement twice. Okay, as you can see that divs1 equals load blah blah blah, and divs2 equals to load again, and same thing, same statement repeated twice. Correct? So that's how we do the self join and composite join and single key join. All right. Now the difference, as I've just mentioned, there are the difference between the join from the relational databases. First, the join should have at least one columns. Okay. In case of our relational databases, there could be a condition on join, and there may be we don't need a condition sometimes. We could simply say select star from A, comma B, and that's all. So, but here in case of pig, you have to have at least one column. Second is join cannot have conditions. Okay. All right. Join cannot have conditions. In case of pig, you cannot have something like join A comma B on value, or you cannot have a condition. All right, so let's have a little bit pictorial representation. What exactly goes on when we do join? So if we have table A with two columns, one is ID and other is name, and we have another table called B with name and ID. If you try to join these two tables, then if we try to join A by ID and B by ID, which means we are trying to join on ID here with this ID. So for ID equals to 1, we we have Sandeep here on the left hand side, and for ID equals to 1, we have Giri. So in output we have one Sandeep, one Giri. For 2 ID, we don't have corresponding one, and therefore we don't get any output. And for ID equals to 3 on the right hand side, there is no corresponding ID on the left hand side, and therefore we don't get that in output. Alright? So is this clear to everyone? So what does it mean by joining two tables? Okay. Joining two tables on particular column means keep only those records where left hand side is matching with the right hand side, and put both the columns from both the tables into a single table, which means the total number of columns in the output will be the sum of the columns in the left and right. Here in the output there are four columns, correct? So is this clear to everyone? Any doubts? No doubts? So we can't use where clause. Right. So here, unlike the where clause in case of our in case of our SQL, here we don't have a similar one. The where clause as represented in SQL is substituted here by filter, and and otherwise the where clause is not there in case of join. That's correct. Okay. What is its usage? So usage is very clear. Whenever we have two data sets and we have to find all the keys of one in another, have you ever used VLOOKUP in case of Microsoft Excel? So whenever we have to intersect two data sets, one with another, then we use joins. Alright? So if you have a table containing the students in this class, and there is another table carrying the marks of all the students in the class, and we might want to find out the email address, and we have to send you your marks in the email. So we will require email ID from first table and marks from the second table together, correct? In those cases, we'll have to join these two tables. Make sense, Lakshmikant and Kalyan? All right, great, great. Any other questions to me? All right, so I'm assuming there are no questions. Okay, so similar to a normal RDBMS, there is something called left join and right join. Okay, left or left outer join. So what does it mean by outer join? Outer join means display the records even if some of the records are not found in on one of the sides. Okay, we'll show you exact meaning, then you will understand what does it mean by outer joins. So there is something called outer joins are of two types, left and right. A left outer join means that records on the left hand side should always go in the output, okay, irrespective of whether the corresponding column is not found, corresponding values are not found in the right hand side. Okay, so as you can see in this diagram, we can either say left outer or we can say simply left. Alright, so you can say join A by ID left and B by ID, meaning the column on the left hand side of the keyword called left is A by ID, meaning this particular column, and on the right hand side of the left keyword is this one, which means that values from the left hand side, which means A should go in the output even if there is no corresponding ID in table B. Alright, so we can have 1 and 2 irrespective of whether there is a corresponding key or not. So for 1, luckily we have key called Sandeep and Giri, and but for Ryan there is no corresponding key on the right hand side. Therefore that is null. Alright, is it clear to everyone? Because I'm sure you will have doubts. Yeah. So is the left outer join clear to you? Or left join, simply left join. So the syntax is join A by ID left, comma B by ID. Okay. So left keyword has to be just before the comma. Alright. So here in case of pig, we generally join only two tables at a time. Unlike in SQL where we can join any number of columns. Okay. Here we join only two tables. Sorry. So in relational databases we can join any number of tables at a time. Here we can join only two tables. All right. Perfect. Perfect. So yes, but more than one column. That's correct, Basra. Now there's something called right outer join. A right outer join is you have A and you have B, all right, and you're trying to join them. So the right outer join means, but the keyword will always come in the middle, and right outer join means that the values from the right will come in the output irrespective of whether there is corresponding values on the left hand side or not. Okay, for example, for one Giri there is a corresponding value on the left hand side, but for 3 Saha, even if there is no corresponding value, it goes in the output. Alright. Okay, so let me change the question a bit. Let me change the question a bit. Okay, so if we had, okay, so what will be the output? Can somebody tell me? In the same manner, the way I was telling you. So it will be 4 Giri. S yeah, okay. 4 Giri, 4 Ryan, and then empty, comma Saha. All right. Yes, that's correct. All right. Good. Good. So let me make one more slide. All right. So here we have the way we have here. Okay. So we will get 1, comma 1. Just give me a second. So we'll have 4 Ryan and 4 Giri, and we'll have, so we'll have empty, empty, correct? We'll have here empty from both the sides, and then we'll have 3 commas. Is that correct? Yeah. Why do we get those empty records? Okay, because we could not find the corresponding value on the left hand side. Okay, and that is something the right join says that even if there is no record on the left hand side, we give the output, and in case there is no record found, just put null over there. All right, Basuraj. Now next question to you is not okay. So similar to that, we have full joins. Full joins means full joins is sort of a combination of all three, left, right, and inner join. So full join means if you can first join all the records which are common to both, and then you list down the records which are not common to both. Okay, it's like a union of all the records. Full join means it's like a union of all the record. Union means values of both sides, but without the duplicates. Okay, is a similar one where so we have got one from left, one from right, and two from left, three from right. But one is only one Sandeep and one Giri is only making a single record. Okay, so it's like combine all the records together and remove the duplicates. Okay, it's like saying take first try to do left and then try to do right, both joins. So is it clear to everyone what does it mean by full join? Great. Now question to all of you is, if we are joining two data sets A and B on the same column, and the total number of records are n1, and when we we do a left join, there are n2 records, and when we do the right join, there are n3 records. When we do we do a full join, okay, how many records would be there? Anyone? So you are saying, Lakshmikant is saying N1. So does it mean that full join is equal to the full join is equal to the inner join? Because in our example, which I demonstrated you just now, N1 was equal to one record, right? One Sandeep and one Giri. So N2 plus N3. Okay, let's have a look at N2 plus N3. So we had right join two records, and we had sorry, we had left join two records. So both the output should have been 4, right? Left join two records and right join two records. The output should have been 4, correct? As per you, Lakshmikant. But the full joins result is only 3 records, correct? So your hypothesis is not correct. So the inner join is n1 records, left join gives n2 records, and right join is giving n3 records. So how many records will full join give us? So are you sure, Baswaraz? So you are saying n2 plus n3, which means 2 plus 2. In our example, it was 2 plus 2, 4, minus 2n, which was 2. That means the result could have been 2 records, but we got 3 records, right? In case of full join. So yes. So Manish and Anand are correct. All right. And yes. Great. Great. And now Basraj also. So is everybody clear on this? Correct. There is one record duplicate. Lakshmikant? All right. So okay, so is everyone with me? Awesome. Great. Next is okay. Next question to you is if we are joining A by ID, B by ID, and we are saying left outer, then what will be the results? This is I will like to warn you here. This is it is more of a teaser. Okay, you might get you know. All right, so it's the first batch who has said wrong syntax. Awesome. So you are paying good attention. All right. Yes, it's a error. It's a wrong syntax. Great. Because, and why is it wrong syntax? Because the left outer should come here before the comma. Alright? Now this one, anyone? Correct. And this one, what will be the result of this outer join? Again, it's a bit of teaser. Alright, so correct. Again, it's a wrong syntax. Why? Because outer cannot come alone. It has to be either left outer or right outer. Alright? Therefore, outer cannot come alone just like that. Any questions here? Alright, great. Next is limit. If we just want to see few records from the input, then we can say limit. Okay. And so essentially, When we are loading a set of records and we say limit divs 10, we get the first 10 records. Okay, we get the first 10 records, that's all. In case of a sample, we basically, when we say load and then sample, what does it mean? It essentially means that give us a random sample out of this data set. Okay, and how big the sample should be, that is defined by this fraction. So we give this value from 0 to 1. We say sample divs and then fraction. Fraction could be something between 0 to 1. Okay, here 0.1 means 1/10 of the total records should be given in the output, and this will be random sample. Every time you run the sample program, every time you are going to get different results. All right, so sample is clear because sample is something which you never saw in the databases. Is sample clear to all? Sample gives you a small sample out of the big data set, and how small, it you can mention it there. And every time the sample gives you a random sample. Okay, and the results of sample are not predictable. Now again, what is the use of sample in real life? Good question. Okay, so ideally, whenever in traditional way, whenever we dealt with data and when we are testing the data, when we are testing certain hypothesis, what we did was we basically took a small subset of the whole data. Correct? Whenever we did that, we basically took a small beginning lines, maybe a small data set, but that always led to a wrong hypothesis because of the skewness in the data. Meaning, first 10 records or last 10 records or middle 10 records may not be the representative of the whole data set. Therefore, whenever you are building a hypothesis or whenever you are trying to test a hypothesis, you should always take the random sample. It should not be it should not be based on your own uh, uh, your own strategies. It should be based on it should be random. You should just get the data from the whole data set. So it has happened quite often that whenever we tested on first few records, and then we said, oh, fine, our logic is fine, everything is doing good. But when we actually test it on the real data, we realized that the query we wrote was wrong because lot of records have different kind of formatting. Lot of records has different set of values, and therefore whatever logic we wrote went wrong because we took a wrong sample. Instead, always test on a random sample. Alright? So in real life, always to test it on a random sample, this is the best strategy to have. Okay? Because in case of big data, you generally cannot do it over the full data set again and again. So generally what you do is you pick a data set, huge data set, run a sample over it, pick up a 10% sample, save it somewhere, and now in future you just load this sample data again and again and keep running your logic. So 10% gives us the randomly selected data set. Alright? 10% gives us randomly selected 10% data. Manish, is that clear? Now here is a question for you. So in this case we loaded a file called file.tsv, correct? We loaded this file and we run dump sum twice. Will it give the same result? Kalyan says yes, rest are saying no. And my question to you is, we computed sum equals sample here, there is only one line here, and we say dump sum, correct? Alright, so here there are two things at, two things in working together. First, whenever we say okay, so every time we say dump or every time we say store, as we told you earlier, it is going to execute all the statement of the pig on which this particular data set is dependent on. So dump sum is dependent on first sample, and before that while sample is dependent on divs, right? So therefore load and sample will be executed every time you call sum. So dump, every time you execute dump, all the data sets on which this particular statement dependent on will get executed. These things say sum is not stored in the memory anywhere. It will be computed only when you say dump. And it is also not cached. Okay? It's not cached, as in we have not saved it anywhere. Alright, it's loaded into memory, it's not saved anywhere. Every time you say dump sum, it is going to go back, first load the file, then compute the sample, and then print. Okay, so loading of the file as well as computing the sample, both tasks will happen twice here. Alright, great, great. So almost all of you were right. This. Alright, because what impression sometimes it gives is, fine, we have computed sample once, and no matter how many times we print sum, we are going to get the same data. That's not correct. Okay, because every time you say dump, it is going to compute load, it is going to execute this and then this. So both of these statements are going to get executed twice because we have dump statement twice. There is no caching, it's not loading in data in between. Alright, okay. So here I'm saying most likely no, because what if there are 10 records, and there are chances that sometimes uh, a coin toss can result in the same side again and again, correct? There is a chance. That's why I'm saying most likely no. Alright, so as we said that the parallelism is the basic premise of pig, means the performance, when we said pigs fly, then we meant that most of the pig is designed for performance. Otherwise we could have simply used hive, but pig is designed for performance. So yeah, that's correct, Anand. So the pig statements are executed when we say dump or when we say store. Alright. So the value, Kalyan's question is, so the value can be from point 1 to 1. So the value can be from 0 to 1 actually. Alright. It could be point 0, 0, 0, 0, 0, 1 and so on. Alright. So again back to parallelism. So, so pig essentially has been designed bottom up in order to give you the best performance. And to give you the best performance, Pig does a lot of things. Okay? And one of them is parallel. Parallel is a keyword which is equivalent to defining number of reducers. Okay? When we ran our MapReduce code, we were able to specify parallel keyword. Alright? When we were running our MapReduce code, we were able to define number of reducers, right? Similarly, Pig provides you the parallel keyword. How many parallel, whatever number you provide here, those many reducers will be created. So, Pig only has impact where there is a reducer code being generated by Pig. If there is no reducer code, no parallel keyword will not have any impact. Alright? So when we say group by, and group by basically involves sorting and ordering and then finding the distinct values. And therefore, when we say parallel 10 again with group by, it would have an impact there. Correct? That means it will create 10 reducers here. Similarly, okay. Now you must be wondering that when we say parallel, it creates the reducers. But what happens when we do not specify parallel keyword? Does it have only one reducer? Okay, the answer is no. It does a little bit of cleverness. Based on the input data, it tries to guess the number of reducers. Okay, so if you remember that, okay, let me take a step back. Let me take a step back. The whole idea about parallel keyword is specifying number of reducers. And if you remember our earlier discussion about number of reducers in MapReduce phases, number of reducers was something we decided. And on what basis did we decide upon number of reducer? Based on how much load is our reducer going to get, if there is too much of data going to the reducer phase or not. Okay, now in case of Pig has no way to figure that out. Pig does not have that smartness to figure that out, that how many records are going to go till reducer phase. Correct? Therefore, what Pig does is it tries to guess it based on the input data set. So input data set goes to the map phase, and whatever is the output of map phase, it goes to the reducer phase. So here, Pig's assumption is that if the input data is bigger, the chances of data reaching to reducer is also bigger. Unless, of course, you can see that in this theory there is a mistake. Say, for example, in our character counting case. After the map phase, we were only left with 26 numbers. So our reduce phase was fairly light. Okay? That's correct, Manish. So pig will only be available, not only available, it will be available for all, but it will not have any impact per se. Okay? It will not have any impact per se. Okay, you can put parallel in with filter, but will not have impact. Now, so based on input data, pig tries to guess. Okay, but it also gives you the control on how many reducers do you want. So the default strategy of pig is for each GB of input data, it creates one reducer. All right. Yeah. So if the data is going beyond 1 terabyte, which means it will have, sorry, if it data is going beyond 9099, then it will not create more than 999 reducers. All right? Okay. Any questions here? All right. So how many reducers will it produce? Again, I'm coming back to the same question. So here we are saying for each means going record by record and applying this what do you call projection. Yes. How many reducers will it produce internally? And remember our reducer logic when we have reducer. So there is no sorting and no aggregation. So there will be no reducer side logic. Alright? Correct, correct. Now, alright. So does parallel has any effect in this? Correct. The parallel does not have any impact on all the pig queries where there is no mapper reducer, no reducer being generated. Alright. Now there's something called flatten. Okay. So what does it mean by flatten? Flatten means that, okay, flatten is just opposite of what group by did. What did group by do? Group by grouped all the other elements together for which a particular column's value is same. So, for example, here you can see that for Sandeep, uh, for C and C++, the key is Sandeep, and now the flatten basically convert undoes the effect of the group by. Okay. So flatten basically will create two rows for this one for Sandeep C and other for Sandeep C++, and flatten will also generate two rows for this one. Had there been say one more here, let me try to put, and if we had Lisp here, okay, then we'll have one more row here, okay, then we'll have one more row and like this. Alright, so it'll be sort of this. Alright, now you can see the meaning of it. Now on this output right here, let us say we had to only find out people who has who has learned C, and we are given this kind of data. So what would we do? We would first we would flatten it, then we will filter it. Okay, we could say filter this data set where where the where the language equals C. Okay, so that is the use case of flatten. After flattening, you can apply filter and order by and group by and other aspects. Or say you had to do inverse now. You are given this kind of data where one person, multiple languages, correct? Now you want to convert it into another format. You want to say for C, find out all the people. For C++, list down all the people, and so on. In all those cases, you will use that kind of form. You will basically flatten it and then group by. All right. All right. So that was our flatten. It is little misplaced. So let's just place it properly. So we have joins order by, group by. All right. All right. So we have gone through the whole thing. Okay. Okay. Great. Great. So the next premise of pig was that pigs are controllable animals. Okay, which means that they are configurable, customizable. In case if in case we realize that pig can't do something, we should be able to extend it. All right. Therefore, pig provides you the ability to call external functions. If your logic is lying somewhere outside, then you can call the external functions. Okay. For example, there is some command which is not there in pig, but there it is there in your Java libraries. You can simply invoke Java functions from within the pig. And please note that pig is written in Java, so effectively all those functions are anyway available in the library. Okay. So if you just want to call a Java function such as converting an integer into hexadecimal number, then you can simply call it. First, you define a function. You can say define my function, and then you invoke for string, integer, or whatever, and then invoke for string as in it will be returning the string. Okay, it will be returning a string. And next is that we say we put the full name of the function which we want to call, and then we specify the argument type, and that defines our function. And uh, from line number 2 onwards, we can use hex we can use hex as if it's a separate function altogether, just like we had other functions like square root and other functions which are predefined in pig. This also becomes the function which you can use in your rest of the queries. Alright, so you can call Java built-in. Next is, say you wrote your own program in Java, you could also use that similar to what we have done in the step number 1. Okay, similar to what we have done in Java built-in, we could use it in the same way, just that we have to register our jar before using it. We will show you this in detail. Alright. Next is calling a Python function. Next is calling a Python function. And calling a Python function is very simple. If you have a Python file, you basically register that Python file. And once you have registered that Python file, what you can do is you can call any of the functions listed in that Python file. A Python file, if you have studied the language, Python file is nothing but a Python program containing the functions or the code of Python. Okay. A Python file can either have only the functions, and it can also have the code. Okay. So when you register, those all functions mentioned in that file become the you can call those functions here. So make sense to you here, this one, calling a Python function. Now as you can see that bball, whatever name we have given, contains a function called production. We are calling that function from that Python file. Okay, so we'll give you a demo of this one. Okay, what is this Jython line? So it's a part of the syntax. In Python there is a library called Jython which basically bridges the gap between Python and Java and Python, and we use that library. Okay. Now Srinivas's question is it mandatory to use hex function while using built-in function of Java? No, hex is just one example. It could be anything. Okay, it could be any function. Right? Just that this line is required. We need to define that what does our function means. What does hex mean? So what does we could also say here my hex. Okay, and then we'll be using that one all across. Okay, so this line essentially says we are defining a function called hex. Okay, and what does it mean? It is basically invoking a function called java.lang.integer.toString, which is returning a string and is taking an integer as the argument, and that is why we call invoke for string, meaning invoke this function, this kind of argument, and it expect a string out of it. All right, Anand. The return value of hex string is string. If you look for it, I will show you. So you can see that this method is returning string and is for 2 hex. It takes an argument of integer type. All right. Now let's try to, yeah, invoke for string is part of the syntax. It's not keyword, it's just a function. It's a function provided to you by pig. Define is a keyword, load is a keyword, for each is a keyword. Okay. Invoke for string is a function to you. And Vivek's question is there must be so many invoke for then. Yes, that's correct. So whenever you are making a call to any Java function, you can use invoke for that particular thing. And yeah, so for all data types, you just have to check the definition of the function in Java, and then you use the same invoke for. All right, that's correct, Vivek. So can we use any other function? Yes. Now Vivek's question is, can we get non-primitive types as well? Yes, you can get non-primitive types as well. Okay, and you can basically cast the result into a map, as uh, we have discussed earlier, that when there is a non-primitive type involved, say you are loading a JSON object. Okay, in all those cases, you can load all of those kind of complex objects into map. Okay. All right, very good question. And all right, now let's take a step further and try to create our own function. Okay, so it's not very uncommon that we face a situation where a particular function is not available in pig, and also a particular function is not available in Java. In those cases, you might have to write your own logic, or if you already have a certain legacy logic, you can use it here. Alright? So what you do is we can basically create our own logic and utilize that one. All we need to do is we have to take it one step at a time here. So the whole project is available in the course page. Okay. So yeah, you can say example here is pig UDF Java. Okay, and you can download this one. So okay, Surya's question is own Java function has convert dividends, but dividend field is not part of input. Can you check? Okay, so uh, okay, our own Java function has convert. Okay, convert something. Okay, but dividend field is not part of. Okay, okay, that's correct. So yeah, it has to be something like dividends dot exch. Okay. I mean, what do I want to say is that's correct, very much correct. I'm so sorry. Yeah, this is better. And thank you, Surya. Very good point. Yeah, so we have to mention that column name. All right, all right. So yes, let's try to first create our own. So this is the URL you can basically download from here also directly. Okay. Here there is pig UDF Java. You can download it. And after you have downloaded inside your Eclipse, what you can do is okay. After you have downloaded and unzipped. So in my case, it is downloaded and unzipped in a particular folder. Alright, let me just open here and let's have a look at it. After you download, you basically go here and click on import and existing projects into workspace. Browse to the folder where you have downloaded it. Okay, so in my case, where have I downloaded it? Let it finish. It's taking a little bit of time. Alright, so yeah, pig UDF folder is there. So similarly, you just pick up the pig UDF folder after unzipping. Here, I downloaded pig UDF.zip and then unzipped it. So after you do that, it will show you one project like this. Okay. Since my project is already imported, it is giving me an error. But for you, you can just select it and say click on finish, and you will have pig UDF like this here. Okay. Okay, so let's have a look at it. So I hope this the font is clearly visible to you. Surya? All right. Great. Now we have so the way we create a new function. So whenever we are creating a function, we have to create a separate class for it. Here we are trying to create a upper function. So we'll use upper like a function. So this might be little confusing to you that there it's a function and here it's a class. Okay, so in this you have first you have to create a class with some name and that has to extend eval function. Okay, after you eval if you look at it, let me delete it. So it will ask us to implement a function, a unimplemented method, and this is where you will have to write your logic. Okay, so I've already written the logic like this. Okay, what does it say? This is my input tuple. Tuple is collection of values on which a function will be applied, and for each tuple you can further, for tuple what is coming in the input. Alright, so each tuple, we have to first check the input, whether it's null or there are no records in it. If there are no records, then we go ahead and we basically get the first value. So, which means if we are calling upper on, we might call in pig upper on multiple values, something like a comma b comma c. Okay. In this case, you can see clearly that we are applying upper on multiple, but according to this logic it will only convert it to uppercase the first value. Okay, and next is that we are saying eval function is string. In case we want our upper function to return say integer, we can use integer here. Okay, we can use integer here like this. Okay, and so whatever we want our function to return, we have to define here and same here, and then we can write whatever we want. So here what we have done is, we in upper we took the input, we converted into a string, and then we are trying to convert it into uppercase. All right, so once you are done with it, what you can do is file, export, jar file. You define the basically this is where my jar file will be exported, and we say finish, say overwrite, and now you have to copy this. So alright, let me try to fit it in. So let me try to copy this. So I'm using SCP. You can use WinSCP. Okay, you can use WinSCP. To student at Hadoop Hadoop 1. I'm trying to copy this file from local machine to Hadoop 1 and into my folder. Okay. You all know the password. Now let's go to our server. Alright. Alright, here we have. Now let me go to my own folder. Wow, so many big scripts are generating continuously. Alright, so and here we must have copied ls minus lrt, means the one which is latest will come at the bottom. So this is our pig udf.jar. So what we can do is we can start pig. Okay, so now pig is started. We say register and we mention. Okay, so we have registered our jar file. Next is that we have already went to this folder. Let's have a look at what does xyz.txt have. xyza.txt has. it does not exist. So cat xyz, that also does not have any data. Uh, uh, I think we are okay now. So this right now we are changing the directory in HDFS. Earlier we changed the directory in the local directory, local system. Okay, now you can see xyza.txt. This file contains some data. We are trying to convert this data into HDFS, into capital. Okay, and using our recently created function. So again, let me go back. We have a package name called myudf, okay, which means like a folder, okay, and under that we have this class called upper, and we will be calling that one, okay. So we say a equals to load, and everything gets loaded into single one, and then we have b equals for each, and we can dump b. Where did you register the jar? At the beginning of the line. So as soon as you start in pig, you say register, and then you specify the jar name. Alright. Now you can see that the data has been converted into uppercase. Alright. If you wanted to do something else, we could actually do that as well here. Okay. If we wanted to just convert first few characters of a string to uppercase, then we could have done that here. Alright. So whatever we want to do, we can do using our custom function. Alright. No questions here? Basras, did you get the answer? So we register in the beginning of the line, if that is your question. Alright. So now I think Eclipse is not required. Okay. Now this was our Java code. We were able to write our Java code. What if our logic which we want to run exists in a code which is not in Java? Okay. Say for example there is a legacy code. There's a legacy code, and what we want to do is in the legacy code we want to run that program against our data. For example, the legacy code exists as a C++ binary or C++, precompiled code, or our existing legacy code is written in Perl. It's not uncommon to have Perl as the legacy code. Okay. And before churning our data using pig, what we want to do is we want to use legacy code to say encrypt, decrypt, or do something else. Okay, or some other business logic. So it's very common to have such kind of scenarios. Whenever we go into production, these kind of scenarios arise. All right. So basically, pig allows you to stream your data through the legacy code. What and again, this streaming is synonymous to Hadoop streaming. In Hadoop streaming, we were given a binary, we were passing our data through the binary and generating our MapReduce. Correct? In the similar manner, in the similar manner, Pig also lets you stream your data through an existing binary, existing software, or you can say existing program or command. Alright? So, and all you have to do is first first you can basically first you load your data, then you can say stream my data through hidiv.pl, and the result we will get is exchange comma symbol comma date comma dividends. Okay. Also, a better way would be, so for example, this program which you are trying to execute, say there could be multiple scenarios. First, this program expects a command line argument as well. Okay. And so in those cases, you can define upfront, you can define that I'm giving this program as a name as HD, and this program needs to be executed with this argument, and also a keyword called ship. So why are we providing ship as the keyword? Why? Because this program may not be existing on all the nodes. Program may not be available on your cluster. Therefore, if you say ship, it will take this program from localhost to all the hosts in your cluster, so that this program is available locally for executing your logic. Okay. Alright. The only thing you should note is if this program is an exe and you cannot execute exe on Unix machine, then this will fail. Or if this program was compiled for Linux 32-bit and you have 64-bit, then this program will not run. Alright? Because here, whenever you are executing something, it involves executing the local command and take the input and output from it. Okay, so the way we do it is define my function, then provide the full command in the back quotes. See, these are backticks. Okay, these are backticks. They're slanted towards the left. Okay, this is not a single quote. Okay, this backtick just above tab key near escape. Okay, on your keyboard. These are those backticks. And why they have put a backtick is so that you can utilize the double quote and single quote in providing the arguments to the program. Okay. All right. And then you say ship. Ship as in the name of the program. It could be an absolute location of the program, or it could be a local location, whatever. All right. And then you say, all right. Now, once you do that, you can use HD or whatever function you have defined, like just another function, and you can pass through your data through it. Alright, so this is clear to all of you. Alright, so a lot of times, whatever you are trying to do, a lot of other people have faced the same challenges and have solved it. Okay, and most of these kind of libraries are available as part of piggy bank. Okay, piggy bank basically provides a central storage where central SVN repository where people keep on adding their code. And when if you want to utilize piggy bank, you can basically check out the data, check out the code from the piggy bank and start using it. All right. So these are the steps. So create a directory for pig, and then you create a directory, change the directory to that one, and then you check out the code from piggy bank and run ent so that it compiles. And once it is compiled, then you can use piggybank.jar just like we did earlier. We can say register piggybank.jar, and that's all right. And so this is the few things you could do. Right? You can have a look at full piggy bank on their website. So piggy bank is good when you want to utilize the contributed code by people. All right. Now next is for each nested. For each nested is a little extension of what we usually do. Okay. For each nested means that it basically it basically means that you can have for each inside another for each. All right. So for example, our problem at hand is find the count of distinct name is in each city. For example, in Bangalore, there is Sandeep, then another Sandeep, then Vivek. So there are distinct names are Sandeep, comma Vivek, and therefore two. While in case of NYC, it's only John. So if we have to do this using pig, what will you do? Anyone? We are trying to count the distinct name in each city. Yeah? So we could simply say group by city, perfect, and then apply count on the whole list. Correct? But what if we want to apply detailed functions on the list, such as filter or order by on the list? Okay. So in those cases, you could basically convert the values into the full data set by using for each nested. Okay. So for example, here we said group by city, and then and also note that here we had to compute distinct also, which we did not take into account. Correct? So distinct is a command in case of pig, and so to apply distinct you need to have the data set in place, and therefore for each will convert this into a data set. Okay, so basically if you look at it clearly, so Surya, you got this. So when you say group by city, what would happen is you will get Sandeep and Vivek, and but you have to first compute distinct and then you have to compute count. Okay. Now, to so basically for each group will convert the whole list of values for group as the data set, and on that data set you can apply all the functions like filter, uh, order by, distinct, and then again for each we can apply and so on. So again we can basically apply for each on people.name. Okay, that is the magic done by for each. All right, just that the last statement in for each need to be the generate, and before that you could use any of the big usual commands. So in generate, group is a keyword. No, group is the column name. So what happens when we say group by? Okay. So when we say group by, if let's go back, okay, let's go back. So where was our group by? Yeah. So what happens here? So you can see here A had two columns. One is age, other is one was name, other was age, and third one was GPA. So A had three columns. The moment we said group by, it created one column called group, okay, of type integer, meaning the same type as age because we are grouping by age, and then the second column was basically a bag, okay. So therefore you notice this, it's a column name. So alright. So here we are saying generate group means first column of GRP and then count. Alright. So that's the magic being played by for each. Any questions? Alright, so we have something called fragmented joins. Okay. Now there are cases where you are trying to join two data sets, dataset A and dataset B. Alright? And where A is huge and B is very small. If you're trying to join these two kind of data sets, then your usual strategy of concatenating two files and then grouping it by a key, and then I mean basically in the map reducer you create a key, and then in the reduce phase you join the data, right? So that whole strategy is a waste of time. Okay, so think about a scenario where you are trying to join two tables. In one table, you are given name and the country name, name of the person and name of country, and all you want to do is translate this database table into person's name and ISD code of each country. Alright? That's what we want to do. And how many countries are there? Quickly. How many countries are there in the world approximately? So close to 200 countries are there. Okay. So let's say there are 200 countries. So this country to code table will be only 200 entries, which is hardly 400 bytes. Okay, or maybe say 1 kilobyte. So on one end you have 100 GB file. Okay, on one hand you have 100 GB file, and on other hand you have only 1 kilobyte file. Now, when you try to join these two tables using usual means, it is highly inefficient. Correct? So, can somebody suggest an alternative? Remember our MapReduce logic where we provided these two files as input, and on whatever column we were trying to join, we created that as the map. For example, in this case, when we are trying to join on the country, we will create country as the key in both the sides, and then let the map reduce join them together, bring them together, and in the reduce we basically translate into output. Now if you see, this involved a reduce phase, correct? And which essentially means this also involved sorting, correct? Can't we just do it on the map side itself? Correct. So Manish's point is that why don't you just cache the small data set, and Basuraj's point is send the small file along with the code in the mapper. That is very correct. So while in the mapper code, why don't we just load the second file, and in the map page itself we basically translate, we load second table into memory, and in the mapper, in a single mapper where we're processing this first table, all we do is we basically translate the country name into country code. Okay, that's an in-memory translation. All right, and we get this result. All right, that's correct, Basra. So now we have, and for doing this, in doing this kind of optimization, you could use a keyword called replicated. So on whatever table you want to cache, okay, whatever table you want to cache or load it in memory, you mark it as using replicated, and rest of the code remains exactly same. So this is another step towards optimization. Is it clear to everyone? So we are saying load persons, then we are loading the second table, and while joining persons and CC, we are saying that against the second table, we are saying use replicated, and so on. Alright? And then you basically, once you have joined them, we can iterate over it and only pick up the columns which we want to pick up. Alright? Now we will have this discussion after a 10 minutes break. Okay, let's take a 10 minutes break. Alright, so can we start now? Alright, alright. So at times, whenever we are joining two tables, okay, there are some too many values for some of the keys, while there are too few for some. And when we say this too few or too many, the ratio is something more than 10,000 or maybe a million times. Okay, 100,000 or maybe a million times. Okay, so in those cases, that when the data gets too skewed, joining becomes horribly slow. Right? And the reason being, so when we are joining two data set on a particular city or particular value, then if there are too many values for one city while there are too few for another, the group by becomes really, really slow. Meaning, in one case we are grouping a million values, in other cases we are grouping only few keys. So, therefore, the reduce phase becomes extremely difficult to execute. Okay, so in those cases, Pig comes up with a new strategy of joining called skewed. If you mark it skewed, it will do a lot of internal optimization instead of trying to create key on a particular column. Okay, it will try to create a composite key and then join. So there are different difference of strategies. So whenever you are joining on a particular key, when you are joining two data sets on a particular key, and you notice that for some keys there are too many values, for some other keys there are too few. In those cases, try to use skewed keywords to optimize the performance. All right. Now, a quick question to all. A quick question to all. Sorting the already sorted data takes equal amount of time than sorting the unsorted data. Okay. So let me again put it the correct way. Okay. So I think I have already mentioned it somewhere. Okay. Let's say we said A equals to sorted data of my file. Okay. Now, how should I say? Okay. Time to sort the data and loading into A takes 5 minutes. Okay. Time to sort unsorted data takes 5 minutes. Time to sort the sorted data as mentioned above would take how much? Okay. So a quick question to all of you. If time to sort unsorted data took 5 minutes and now you are resorting this data, okay, whatever you have sorted just now which has taken 5 minutes, if you're trying to resort it, how much time do you think it will take? Anyone? So Surya says less than 5 minutes, definitely. Less than 5 minutes. Okay. Anybody else? Trust me, the answer is going to be surprising. All right. All right. So it takes basically, yes, correct. So it is going to take close to 5 minutes. And you will be surprised to know that for some of the algorithms, such as binary search tree, the performance was horribly slow. Horribly, horribly slow. Okay. Okay. So as our assumption is that if you have already sorted, then we don't have to sort again. No. Okay. So basically it will take minimum of 5 minutes. Okay. There will be no difference in the performance generally because most of the algorithms have evolved, although most of the sophisticated algorithm suffered a lot of problems when sorting the unsorted data. Even the algorithms like binary search tree, it took a lot of time to sort the already sorted data. Okay, so therefore Therefore, sorting the sorted data or unsorted data takes almost equal time. All right. Unlike we humans, even if you are trying to sort a data and you don't know upfront that whether the data is sorted or not sorted. In those cases, it's going to take equal amount of comparisons to figure out that the data is already sorted and we cannot leave it as is. Okay. Now, some of you might argue at this point that why don't we first scan and check whether the data is already sorted and then sort it, right? The thing is, if you do that for most of the cases, whenever your algorithm is being called, for most of the cases, you would not, it will be waste of time to basically check whether the data is already sorted or not. Alright? So, yes, it will take maybe more than 5 minutes. All right. Okay. So therefore sorting the sorted data, so say for example you have just done a query or order by just now on a table. You have two tables already sorted by the same key on which you are joining the two tables. In those cases you can basically join the two tables as is without involving any sorting, correct? And you can specify using a keyword called merge. You can say using merge the way you have skewed. Okay, so the way we had replicated, join using replicated, join using skewed, join using merge. Okay, so we talked about three kinds of joins. Okay, one was replicated, other was skewed, other was your using merge. Merge we use it when both daily as well as divs are already sorted by a particular symbol. Alright? Now, it's also quite often that the columns on which you are joining the two tables, you will also group it. So this is a common thing, and that's when Pig comes up with a new syntax called co-group. When you want to join the two tables and group by on the same column on which you are joining them, then you can do co-group. So in this, we are trying to join on animal and then group by on animal. Okay, and and that's what is the result. So you can see that for cat, for if you see for cat, okay, and for cat it's Adam and Alice, okay, and or you can see that for cat we have Adam cat, and on this Whisker cat, and Paws cat, and Alice cat, and when you group it, then it'll be all the cats have come together here. Okay, all the four values which come after joining, and same is case of dog and then. Okay, so basically joining and grouping by is called co-group. Alright, so sometimes you just want to append two data sets together, then you can use union. In those cases you can use union, and union is basically putting the data of one above another. So when we say union A comma B, it's equivalent to concatenating the two files. Alright, and that's the role of union. And there is another extension to union called onSchema. When we want to match the schema of two files, we have two data sets A and B, A having X and Y columns and B having Z and X. In those cases, the the output it will generate will be X, Y and Z, and the records of A will only fill X and Y column while Z will be empty. The records of B will only fill Z and X. There'll be one on each other. Okay, so that's the way it is. Alright. Is union on schema clear to everyone? I will show you an example. So I'm sure normal union is clear to everyone. Alright. So, okay. A better way to do it would be using alright, so I think this will make it very clear. So you have X and Y, okay? Alright, so you have X and Y. So this is your one database, database, the data set, and this is your another. And when you union on schema, what happens is you get these three columns. Okay? So what's happening here? So what's happening here? We have X and Y. There are two columns in A. This is, you can say A, and this is B, and this is union on schema. Alright. Now what's happening is when we say union schema, out of this X, Y, and XZ, we get three columns X, Y, and Z. Okay. And first all the values of A would come, A11, A12, or you can also say first all the values from B would come. So A11, B12, so A11, B12, and B21 and B22. Okay, the value of X in case of B is how much? B21, uh, okay, B12, and Z is A11, and so on. Okay, is it clear now? Does it make sense to you? This is So what we have done is, here what pig does is it creates the total union of all the columns, which is X, Y, and Z, and then tries to fit the data from both the data sets. So when it tries to fit data from B onto our schema, this is what it results. This is null. And similarly, when it tried to fit the data from A onto this is what we get. And on what basis it tries to fit? Based on the column names. Is it clear to all? Alright, great. So I think I should better just copy it to the slides. Yeah. If we do not specify on schema, will there be 4 columns? No, there will be only 2 columns. There will be only 2 columns. Okay. If we do not specify on schema, then there will be 2 columns. Alright, so Kalyan's point is the result is same without schema also. Hit accept null. Yeah, result is same, yeah. Total number of rows are same, Kalyan, in with or without schema. Alright. But the way it has been placed under columns is different. Alright. In case you do without on schema, there'll be essentially 2 columns. Okay. It'll look like this. And let me just, so it'll look like this. It'll look like this. There'll be no such thing called. Alright. Okay. So this is for on schema. This is for on schema. And this is normal union. This is normal union. Okay. Alright. I hope this is clear to everyone. Great. Alright. So there'll be no column name, there'll be no schema. If normal union, I'm answering Anand. So in normal union, there'll be no no column names, no schema at all. And if you remember correctly, in pig, it's okay not to have schema, right? All right. So what will be the result of this join? Join A comma B. Correct. We should mention the name and it will give an error. Okay. And what could have been the result in case of our RDBMS if we join the two tables without specifying a constraint? If we are trying to join the two tables without any where clause in case of RDBMS, what would happen? What would it give? Yes, it does work, but what will be the result? Both the tables data, but in what manner? Is it just like union or what does it do? Correct. It is Cartesian product. All the records from A combined with all the records from B, which means if A has n number of records and B has m number of records, the total number of records after joining A and B in case of relational RDBMS, total records would be n into m. Okay, that's correct. So when in case of pig, if we do this, we will not get the Cartesian product. Instead, we will get an error. So the question is, how do we get the Cartesian product? If we try to do a cross of A and B, how would can we get the Cartesian product? Okay, so that's the question. So how do we get it? Using a syntax called cross. Okay, so using cross, you can basically cross multiply two data sets, daily and divs in this example, and generate all combination of daily and divs. Okay, and that too, here parallel syntax makes sense to some extent. Okay, and it basically uses standard users. Okay, in this example, although without parallel, this is also a valid syntax. Okay, so basically both are equally valid. This one, all right. This one and this one. Any questions here? Okay. Now, as we already talked about, Pig is more likely a analyst tool. So whenever you need to do data churning, or you mean to say the business intelligence reporting, or kind of preparing various kinds of report for various people, you would be using Pig. Okay, for uh, the analytics. And in all of these cases, you will notice that after a point of time, you will have to use the parameter. Say, for example, every day you want certain detailed reports on data. Say, purchases made yesterday, purchases made in last 3 days. Okay, so whenever you are executing such commands or such queries, you will need the current date. Okay, you will need the current date, and therefore you might like the flexibility of having the date as external to your program, which means you want to create a parameter for your pig script, okay, so that you can run your pig script for different parameters without having to change your pig script every time. You should be able to specify the parameters from outside. Okay, so pig provides you all that. Pig provides you a way to specify arguments. Uh, Okay, say for example you have created a daily.pig. In that you would mention dollar variable name, whatever you expect as a parameter, and then you can pass this parameter from the command line. You will pass this parameter from the command line saying pig minus p, your variable equals some value, and then the script name. Now, what if your parameter become too many? In those cases, you can create a separate file in which you can list all the parameters. And once you do that, you can say pig minus param file is this and my script is that. Alright. Also, there is a syntax called splits. Okay. What does splits do? It splits one data set into multiple. And it's not really, splitting per se. It's like copying the data. Why? Because a record might go into multiple data sets. So here what we are trying to do is we are splitting a data set called wlogs, and wlogs is loaded from weblog file. Okay, we are splitting wlogs into three different legs. One is uh, April 03, 02 and 01. And if you notice in these conditions, a record might not go into any of the data sets, or there could be few records that would go into all the more than one data sets. For example, for the all the records that have come before 4th of April 2011, those all the records will go into April 03 and April 02 and April 01. Correct? But the other record, like all the record of 2012, are not going into any of the leg. Okay, so this is a splitting of the data set into multiple data set, and okay, so this is useful in the cases where there is a big single file and uh, you want to basically process it using different logic parts of it. In those cases, you can split it. All right. Now, few things to note about pig is non-linear execution, meaning, as we had already said in our discussion earlier, unlike our usual C program or C++ program or Python program or Visual Basic program, in those all programs, there was one thing in common, that statements executed one by one from top to bottom, right? Here, that is not the case. We declare statements. We say A equals to load something, B equals to filter A, or C equals to load something, and D equals to join A and C. We define these things. So when our pig script gets executed, although the evaluation of your commands happen from top to bottom, but the execution of each command depends on how depends on our dependencies between data sets. Okay, a better example would be, imagine that you have A equals to load, B equals to and again load, C equals to, okay, join okay, C equals to filter A, and D equals to again load sorry uh, group by A. Now if you if you have this kind of a syntax, if you see, and we say dump D, correct? What all statements would get executed in this? Can anybody tell me? We have A equals to load something, B equals to load something, C equals to filter A, D equals to group A, and we say dump D. So line number, which all line numbers gets executed? Correct. The line number 1, line number 3, and line number 4. Line number 2 is not going to get executed here. Okay, this will not execute line number 3. Correct? Okay, so this is what it is. All right. So and you can clearly see that line number 3 did not get executed, and therefore it's not really a linear flow. Linear as in our normal program, if we have print A, print B, print C, print D, our A, B, C, D will get printed. Correct? Oh, sorry, line number 2. I'm extremely sorry. Line number 2 will not get executed, which is this one, will not get executed. Okay? So, that's what is called as nonlinear flow. Also, in case of, say, for example, we were talking about a split, right? And we had multiple filter statements. So there are, say, filter A, and we have C1 here again, filter C, and then we have C2 equals to filter C1. Okay. Now these three statements might get converted into a single map. These three statements might get converted into a single map in order to optimize the map's performance. All right, and so that is basically Pig tries to do all of these optimizations under the hood. Okay, based on your Pig Latin. All right, so that's pretty much about Pig. The general documentation of Pig is available here, and also the custom load functions are available here. So go through these, and in the meantime try to finish the quiz provided to you on the website. Here there is a Pig subjective question. Okay, Pig subjective question, Pig basics, and also try to execute the UDF by yourself. When we write pig commands on data, do we use MapReduce? So pig internally use MapReduce. You do not have to, write your MapReduce. Does it have trigger like Oracle or MySQL? No. Pig is not really a database. Pig is more like SQL query executor. You give it query, it will convert to MapReduce, get it executed, and give you the results. Okay, so you can click on start the quiz. All of the quiz is based on the main question here. Okay, we have a subjective question here. Download the tweets. Tweets are in these three columns. Users have these three columns, and then solve the rest of the questions. Okay? And also try to finish the subject these objective question. It has 33 questions, so please finish those. It should not take more than 5 minutes of your time. You can take this quiz multiple times, meaning if in first set you could not do better, you just attempt it twice, and then that will make you learn really well. Alright, so that was pretty much about pig, and today we are on session number 7. So we'll go into Hive basics now. Alright, so thank you very much for the pig. Let's start with Hive. So, okay. Manishi's question is, can we use pig for cleanup? Okay. Best book for pig, I think the online documentation is best. Okay. Online documentation is best out of all, the one which I have referred. Okay. So, if I compare book and the documentation, I like the documentation better. Can we use pig for cleaning? Cleanup as in cleaning the data? Yes. Pig can be used for cleaning up the data, or it can be used for any kind of data churning. Do you have any example of ETL using pig? Alright, so the example which we have a subjective one here, try to do that, okay, and you will get a fair amount of idea what kind of ETL you can do using pig. Alright. Those who are not aware about ETL means extract, load, and transform the data. Alright. So, alright. So basically it goes through the Twitter data, try to combine that, join that, and then you can. Okay. Alright. So okay. Any other questions on pig before we move on to hive? No questions? Alright. Alright. So during this okay. So there is no doubt about the fact that MapReduce is even difficult for the developers, and there is a lot of repetitive logic. Even experienced developers find it difficult to convert a problem into MapReduce. Okay, so so we need some other tool. One was Pig, and next one is Hive. So now question is why would people you have Hive when we already have Pig? So on one hand, Pig is really efficient and gives you more control in handling big data. Okay, because it provides you various kinds of we talked about replicated joins, we talked about skewed data, skewed joins, and we also talked about various kinds of parallel commands. So while pig gave us enormous amount of capability to churn the data, but there are already so many people who are quite used to the traditional SQL. You cannot train lots of people to move away from SQL immediately and start using pig. Also, there is already so much of SQL written, you cannot expect people to start migrating it. So, people thought about this thing and came up with Hive. Hive is similar to Pig. Hive is a query execution engine. It takes your query, converts it into MapReduce, and executes it on the cluster. That's what Hive is all about. Okay. Now, the value proposition of Hive is it's most suitable for data warehouses. Also note that when we talk about Hive, Hive basically takes your query, runs it on the database, and converts the input into output. Alright? Now, there are few catch you must notice. First, Hive does not provide a insert into or update data kind of syntax. It does not let you alter the data. Okay, therefore it is good only in the cases when we have to analyze the static data. Okay, though we can basically create the full table by using insert into, but we cannot have things like alter table, we cannot have things like update data or insert into data. All right. So, so essentially, we cannot have the record-wise processing in Hive. Therefore, therefore, it's good when the data is relatively static. Other is when we do not require fast response time. Okay. So when the data is huge, but you don't require for fast response time, you use Hive. Otherwise, if your data is smaller, you can as well be happy with your usual MySQL or other databases. Alright. Now, since it accepts SQL, it tries to be compatible with most of the SQL variants, and therefore it makes it possible to port existing projects. It provides a SQL dialect called HiveQL, which is basically sort of a superset of all the main dominant SQLs out there. Okay. Now, unlike Pig, in case of Pig, we did not have any data storage. We loaded data from HDFS or third-party places and stored at the third-party places like HDFS or HBase. But in case of Hive, Hive has its meta store. Okay. Why? Because when we are defining table, in case of pig, right? In case of pig, when we said load A from this file and then we did some things, all of these data sets are transient, meaning as you disconnect from pig, these data sets will disappear. If you connect again, you will have to recreate these data sets. But in case of databases, if you remember, when we created views or when we created table, those tables persisted, right? Those tables persisted. And therefore, Hive also provide you a way to keep your metadata or tables in place so that you don't have to keep creating these tables again and again. And therefore, it maintains a meta store. Basically, it stores its metadata into MySQL. Alright? It allows you to query HDFS and HBase. So these are the value propositions of Hive. Here are the limitations. does not provide record label editing, such as update, insert, or delete, cannot generate, but can generate, it can generate the new tables or new file. Keep that in mind that it is not suitable for online transaction processing. Reason being that since it runs on it runs on top of Hadoop, it basically takes a similar kind of latency, or it gives you similar kind of response time. Meaning, MapReduce jobs are fairly slow, perceived as fairly slow because there is a boot up time involved, and moreover, most of it is batch processing in the sense that you say to Hive that here is my query, get it done, and respond to me. And MapReduce takes your queries and does the job and gives a feedback. Okay, so basically you are at mercy of MapReduce to get your work done. All right, and therefore it's not in real time. It's not in real time. And that means that MapReduce, any query which Hive is going to execute, is going to take similar amount of time like MapReduce, and therefore it's not great for OLTP, online transaction processing. Okay, and also there is also a boot up time because it has to convert your SQL into MapReduce. So that's another boot up time required, and therefore it does not suit as OLTP. It's great when dataset is maintained in mind, meaning the dataset is relatively static, okay, and the dataset is large. Only then you see the value proposition. This is the architecture diagram of Hive. The architecture diagram of Hive is like this. At the bottom level, we have Hadoop. Hadoop has master, and Hadoop master has job tracker, task tracker, and there is a file system. So that's Hadoop. Now in Hive, the core of the Hive is the driver. Okay, so what does driver do? It takes the SQL from you, converts it into MapReduce, gets it executed on Hadoop, and gives you the feedback. So that is the driver, and it is the most important part of Hive. Rest of the components of Hive are going to use driver directly or indirectly. Okay. So for example, if you say select star from my table, it will basically go to HDFS and get all the data and dump it to you without executing MapReduce because you have said select star. You want all the records. So those kind of things, those kind of optimizations are done by the driver for you. Alright. Now, driver can either be called from command line interface. This interface is what we are going to use the most. Or driver could be used from Hive web interface. This is a web interface also. You can log in into Hive and you can see the Hive web interface. Next is that there is a thrift service. Thrift service is a service architecture. So thrift service are very common in open source world. The thrift as a product comes from Twitter. It's really fast for creating high throughput services. Okay, just like SOAP, so SOAP, SOAP, REST, and other models. Thrift is also a service layer architecture, and it is probably the most popular and most efficient amongst all the competitors. Alright, so thrift server is one which makes it possible that you write your query, you write your implementation in Java, and your client is available in all the languages, which essentially means that Hive's client, which means Hive's client which can call Hive and execute the queries, that client can be written in any of the languages which Thrift supports, and those languages are more than 100. Okay, so basically you can call Thrift from any programming language. All right, so Thrift can also be called from ODBC, JDBC, or anywhere. Okay, so this is the general ecosystem, general architecture diagram of Hive. And this is a quick view into word count problem. Basically, all it does is load the data from a file into the table and then split the data by space. After splitting the data, it explodes as in converts array of words into one record containing one word, and then it does the group by and gives you the result. Okay, even if you did not understand, do not mind that program. The objective was to show you that it is just like SQL. Alright, for you to get started, you can SSH into Hadoop 1 or Hadoop 2 and then either execute a Hive command. Okay, after SSHing into Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, you can either execute Hive, which means you will get an interactive cell where you can type your SQL query and it will give you the results, or if you already have created a SQL statement and you just want to execute one, you can say Hive minus E and specify the statement, and once it executes, it will exit. Or you can write down all your SQL into a single file and execute that using Hive minus F, right? And Hive's most simple table would be this format. You can say create table and table name and then column name, and then you can select star from X and then drop table X. Okay, this is most simple one. All right. Now you can log in into Hive, and on this Hive prompt, you can execute Hadoop DFS commands, meaning HDFS commands, like DFS minus L, or load another script like this, just like shell or batch script. We can load Hive script into the current running interactive cell, and you can comment out the code using dash dash. Also, you can define environment variables which can use in your query just like we did in Pig or any other programming languages, and execute shell command with exclamation, local shell commands using exclamation. Let's have a look at it. So let's exit Pig and execute Hive. Any questions till now? No questions? Hive does not support, it does support multi-line comments, I'll show you. Correct, that's correct, Srinivas. That even Pig also convert our queries to MapReduce. Alright, now we have loaded Hive. Okay, so we can say show databases. Alright, I can say use sgiri. Alright, next is we can also start, so that was SQL, we can also start DFS minus ls. It will basically show you the list of files on HDFS just like Pig, and we can basically execute local commands also. So this is our local commands. Alright, so it executes local command, and that is, yeah. So you can also try to log in parallelly and you can start working. Okay. All right. So that was a little quicker view of how does a Hive prompt looks like. Most of our work will be focused around Hive prompt, although you are free to use the web interface as we were talking about. So you can basically go to here. So here you will see H catalog. It will show you all the tables and databases present right now. So here, where is my table? Where is my database? This is my database. My database has these tables. I can click on any of these tables and have a look into it. Okay. And then we can also execute our query. So this is sort of table browser, and here this is the query editor. So you can either do it from the browser or from the command prompt. And there are also drivers available as of today in your there are also drivers available as of today in your uh, reporting engines such as BERT or Crystal reports that connect to the Hive and execute the queries on Hive and present the result back to the user in a well formatted manner. Alright, so we have data types. So the data types look very much like your usual SQL. The only thing to remember here is that you will notice there are multiple data types for the same thing. For example, Boolean and binary, both of these data types do the same work. Similarly, string character and varchar, all of three of them do the same thing. Now you might ask, then what's the point of having these multiple data types for the same thing, right? Why do we have boolean and binary? Why do we have string varchar and char? All of them. What's the point? So the idea is, as we told earlier, the value proposition of Hive is to be able to execute any SQL, whether that SQL is from Oracle, whether that SQL is from Postgres, or that SQL is from Microsoft SQL or MySQL. So in order to have the minimum changes required to execute a SQL command onto Hive, what they have done is they have tried to bring the syntax from all the databases to a single place by having the common data types, having the same data type, having the same functions, having the similar syntax. So they have made it possible that that to run Oracle script, you would not have to change too much into the script. Okay, so that's the reason you will notice there are so many data types. Also, other than the basic data types like integer, float, decimal, and date. Other than the basic data types, they also have a complex data types. Complex data types such as arrays. Arrays is a list of values. Maps. Map is a key value pair where key is not predetermined, while struct is again key and the value, and keys are predetermined, as in we know that our struct will only hold this kind of data. All right. Now, So for example, and there is union. Union is good if you are trying to store multiple kind of data into a single column. And you know that only one of the data types out of multiple kind of data type, only one will be available at a time. Okay, so let's have a look at it. So we are trying to create employees table where name is the string, salary is the float, subordinates is an array of strings, okay, array of strings, deductions is a map of a string and value, and okay, map is so address is struct meaning that it will have a predefined set of fields such as street, okay, while city is simple string, state is string against string, and state is a struct containing zip code. Oh, sorry, what am I talking? So yeah, so address is a struct containing street, city, state. Okay, so basically the address here is a state. So just a second. Yeah. So address here, let me just format it well. That will make more sense. Yeah. So you can see address is a struct containing four keys. One is street, city, state, and zip code. All right. And also struct can have inside it another struct and so on. Then authentication. How did this user log in? Did this user log in using Facebook, Google, or email? Now, had these three been a single kind of data type, then it could have been easier for us. But if one of the data type is int, other is string, then it's very much required that we define it like a union. Okay? So you are trying to store data from same data but in different format into the same field. So the definition of union and struct is very much like your C plus C. Okay. So is the definition of union clear to everyone? Yeah? No? Alright. So let me repeat. Let's say here again I'll take the same example. A user can be authenticated using Facebook, Google, or email. So when you are logging into some website, either you can log in using Facebook authentication or Google authentication, or you can sign up and specify your details. Now the question is here, if Facebook, Google, and email, all of them provide you ID in the same format, say string, then you don't need to create the authentication column as union. You can simply say auth is a varchar or string, correct? But since Facebook ID, Google ID, and email ID, all three of them have different data types, then we have to use union. Yes, we define data types and arguments in union. No, so Hugh does not use, in our case, so I missed Mohan's question. What does Hugh use? OpenAuth for authentication. So it can use OpenAuth for authentication, but right now it's using the plain login password. Alright? So this way, basically, we define union out of Facebook. So FBID, GID, or email ID, only one will be present at a time. There will be no situation where more than one is present at a time. Okay, so that's union. So a union is similar to like a C programming. Is that clear better now, Basuraj? Okay. Okay, okay. So Basra's question is, so auth column will accept data in any of these defined format. That's correct. Okay, Kalyan's point is, struct is more than one field of same type. Okay, where did it go? More than one field of same type. Union is one field and different data type. That's, yeah. So that's a way you can look at it. Yes, auth column will only accept the data in either of the data types. All right, great. Going ahead. Now, you can create your database. Before starting, you should create your own database. Just I was showing you, should show databases, it should list the full databases. Then you can create your own database, and then you can go use your own database and also use describe to see the database details. Okay. In case you want your database to be displayed on the command prompt, you can use hive cli.print current db equals true, and it will show you the database name in the command. Okay. Also, you can drop the database, existing database, and okay, and also use if exist command in the database name. Okay, so create your own database and try to execute commands over there. All right. So inside a database, you can say show tables, select star from table, and describe my table, and describe extended or formatted. Okay. So, okay, Mohan's question was, yeah. So yeah, that's what I was trying to answer. So when you are using hue here, using Hue, you can either supply your login password like this, or you can use, I think instead of OpenAuth, I think it provides Kerberos. Okay, integration with Kerberos. All right. So have a look at that. Okay. So you can see the tables here. We are on the prompt. We are seeing show tables. So these are my tables. If you want to see what's there inside a particular table, say tweet simple, we can say describe formatted and our table name. It will show you the full detail of what is inside. So you can see that these are the columns defined in that particular table, and the other information like database name is this, owner is Asgiri, creation time is this, last access time is unknown, and table type is the virtual view. It's not really a table, it's instead a view, and this is the SQL query that represents the view. Alright, so that's about our Hive. Alright, also you can quickly see show tables, and you can say select star from employees. You can see that. So that way you can start querying the database. Alright. Now there are two kinds of tables in Hive, managed table and extended table. The difference is not much. The only difference is that when you drop a table, the data will disappear if it is managed table. If it's an external table, the data will not disappear. So while creating a Hive table, make sure that you take the correct decision and prefer an external table over a managed table. Reason being, when you drop the table, the data gets deleted in case of managed table. So always prefer an external table over a managed table. Okay, so all right. So whenever we are creating our table in Hive, so what does it mean by creating a table in Hive? First, we create the information like our database, our table is going to contain these 5 columns, alright? And our data is going to be in HDFS at this particular location. Okay, that's the meaning of creating or defining the table in case of Hive. Okay, so managed tables are internal tables. Lifecycle is managed by Hive. Data is stored in the file you added. Okay, and so almost all the tables which you do not specify external, they are all created as managed. Now external table is where data is owned by somebody, and you say that this is my external table pointing to that particular data. And Hive does not own the data. In case you drop an external table, the data remains intact. Data is not deleted. All right. Okay, so the Hive meta store, which we talked about, stores the metadata of tables into a database. Okay, and metadata, what does metadata store? Metadata basically includes what all DBs are there. Okay, what are we created a database, we saw the database. So what are the databases, what are the tables there, table definition, name of table, columns and partitions, etc. All right, so that is Hive metastore. And Hive metastore is nothing but use your normal database. You can have a look at MySQL. So here you can see tables. So Hive essentially is storing the actual metadata into MySQL. Okay. So here I think information schema is the one that contains. Okay. So let me try to log in. So databases. Yeah, here is the Hive because I logged in with root now. You can see there is a database called Hive. So Hive stores its all information in Hive database. So here you can see show tables and show tables. There'll be a table called TBLS. In this our Hive would be storing all the data. Okay, you can see that all the information, whether it's a view or anything, it's all stored here. You can see the student is a table, okay, and it's a managed table and so on. So everything is stored here. So the metadata which we are going to create, it's going to remain there. If we are creating a table in Hive, even if we disconnect, the table is going to exist. And how does it exist? By getting stored into metastore. Alright. Alright. So yeah. So this is the metastore. A metastore stores everything about of a table. The data is stored in HDFS. Remember that? The data, underlying data of a table is stored in the HDFS. So let's create a simple table. This is our simple table. What does it have? Can we connect to Hive through JDBC. Yes, definitely, definitely. You can connect to Hive using JDBC. Alright? It provides you a JDBC driver, and you can basically connect to the JDBC from anywhere. Okay? So here is our table. What does this table say? This is our managed table. Okay? Here what we are trying to say, we are saying create a table, this one, with these columns. Okay, these columns, and row format is delimited fields terminated by /t, and location is this particular folder. All right. So here the extra things from relational databases is these two. First, we are telling that our data is lying in an HDFS folder at this particular location, and we are also telling how is our data formatted. Okay, so now you can see that Hive is not storing data anywhere. It's basically putting the file as is into HDFS and providing you a way to look at it using SQL. Okay, so let's create this table. So what does it say? It says you have an error in the syntax. And what does it say? Create table near string. Near string. Which one is the error? Can somebody spot an error here? Why it is so? Oh, thank you so much. That's correct. Thank you so much, Anand. Yes, I am supposed to be in a Hive prompt. Great. Alright. Basic question from Mohan. If Hive is handling only structured data, why did we need Hive and why not other existing querying tool? Okay. So basically, I did not much get the question. So let me rephrase what I've understood. So if you mean to say that when Hive is basically handling the structured data, okay, why don't we start using the usual tools? Okay. So Surya's question is, so Mohan, I need to understand your question first. Could you rephrase it? In the meantime, I'll try to explain Surya's question. Surya's question is, will it handle unstructured data? So for Hive, handling unstructured data is too much of a task, because in case of Hive, we need to define all the tables as such. Okay. So So therefore, in case of Hive, it's difficult to handle unstructured data because Hive is very particular about defining tables with the full data definition. Unlike Pig, in Pig, we could load plain text file easily and churn the data and then get the results. But that's not the case in Hive. So Hive does not do a great job at the unstructured data, right? Was that does that answer your question, Surya and Mohan? It doesn't do a very great job at handling the unstructured data. Okay. All right. So, okay. So, if you have any question, drop us an email at hadoop@nobigdata.com and feel free to get in touch anytime. And that's pretty much. We are already running 4 minutes past our usual stop time. We will discuss things tomorrow again at the same time. All right. But feel free to finish your pig questions. It will be easier for you to just finish it now than later, because later you will get out of context and then it will be difficult. All right. So have a good day. Okay. Mohan's question is, then why not MySQL other tool to sit on top of Hadoop? Because everybody is trying to do that, Mohan. Okay. But the thing is, to port MySQL to Hadoop is not straight away possible. So things are being moved one thing at a time. All right. There are few things where the basically we cannot, technically it's impossible to use MySQL on top of Hadoop. People are trying their best. All right, and we will discuss things tomorrow again. And see you. Bye bye. Have a good day. Okay. Thank you, Kalyan. I'm happy that you liked the session. All right. So feel free to refer your friends for our next session, which is starting on 30th of May. Okay. Our session is starting on 30th of May, and feel free to refer your friends. All right. Bye bye. Have a good day. Yes, 10% cashback, of course. Yes. All right. See you.